Hello again, everyone, and welcome back to our course in college algebra. Dr. Tom McNamara here, talking about synthetic division. So this is a technique that will help us find factors of polynomials. Now, you'll remember from our last couple of videos that if you're dealing with a polynomial function, there are three key things that you need to figure out. And if you do figure these things out, you can basically answer any question that anybody would throw at you involving a polynomial function. And of course, those three things are the end behavior of the polynomial. And to know that, you need to figure out the degree of the polynomial and the sign of the lead coefficient. And once you do that, you know, okay, does it end like this, that? You know, we have those four cases. And then we have this little triangle here. The zeros, the x-intercepts, and the factors. If you know any of these things, then you automatically get the other two for free. So in particular, if you get the factors, you got what you need from this section. And then does the polynomials graph cross or just touch the x-axis at the various x-intercepts? So if you know any of those, then you know everything. So let's look at a quick example here. In fact, let me give myself a lot of space to write this. Okay, so find the factors of, and I'm going to steal an example from a textbook that I've got sitting here, x cubed minus 2x squared minus 5x plus 6. Okay, so we are tasked with finding the factors and finding the zeros. Those are equivalent, right? So, in the examples that we looked at in the previous couple of videos, I did factor some polynomials, but there was always a common factor I could take out to get me started. And here, I don't have one. I'm out of luck. So just like with arithmetic, if we can't see the factors by inspection, we can use the division algorithm to figure out whether or not something is a factor. So here I'm going to have, so this is what I'm going to do. I'm going to test. Is x minus 3 a factor? Okay, that's what I'm going to test. And the way I'm going to do that is by setting up a synthetic division algorithm. Okay, so we got a number here in a notch. What goes in that notch? Well, answer this question. What makes the divisor 0? So we're testing x minus 3. What makes that 0? X equals 3. So that goes in the notch. On this line, we've got the coefficients of our polynomial. Give me a blank line right there and draw a line underneath it. Okay. So here's how we start the synthetic division process. Whatever is here, drop it down. And then multiply by 3. Why? Because 3 is in our notch. So that tells me what to write here. It's a 3. Add these numbers. That gives me a 1. Multiply by 3. which gives me a 3. Add these numbers. That gives me a -2. Multiply by 3. Okay, so notice, whenever I get down to this line, whatever I have, hit it with 3, and that's what you put here. So multiply, add, multiply, add, multiply, which gives me a -6, add, give me a 0, put a little separator right there. Okay, the reason I separated that last number from the rest is that's the remainder from this division. So my remainder is 0, so the division has gone in even. That means x minus 3 is indeed a factor of this polynomial. And these numbers here, these numbers also tell us something. Those are the coefficients of the quotient. Okay, so what we've learned is that this polynomial up here, f of x, is equal to x minus 3. We tested whether that was a factor. We saw it was a factor. X minus 3 times 1x squared plus 1x minus 2. Okay? So this original polynomial factors into the product of these two polynomials. And we will discuss in a later video how you can determine what you should try for factors. But right now, just take this as gospel. This guy is a factor, that's the other factor. And we can go even further. This is a quadratic. We know how to factor quadratics. We look at the constant term, it's a -2. Now we're thinking of numbers that multiply together to give me -2. Not too many options. +2 and -1, or -2 and +1. We want the combination that adds up to 1. So you choose +2 and -1, x plus 2 times x minus 1 gives us this. So now we factored the whole thing. Okay, so the synthetic division was useful to get us started because I had no idea how to try the factors other than doing a division. Okay, so I want to show you a couple of other examples of using the synthetic division process. So another example, we're going to divide, and let me go and pull one from a textbook that I've got lying around here. We're going to divide this polynomial, 2 plus 6x power 4 minus 9x. We're going to divide that by the polynomial x plus 2. And we're going to use synthetic division. Okay, so got our notch, and then we'll have the coefficients of the polynomial. All right, now, this is going to be a little tricky. So, starting with a 6. Why? Well, what we need to do is we need to write the terms in descending order of the powers. Okay, so really we should think of this as 6x power 4 minus 9x plus 2. Got to write everything in order. So whatever you write first, that should be the coefficient of the highest power of x in your polynomial. All right, the 2 is the constant term. That's x to the 0. This is x to the 4, so that needs to go first. Now, that was the first tricky thing about this. Another tricky thing. A 0, another 0, a -9, and then a 2. Okay? So as we discussed, this coefficient is coming from x to the 4th, because that's the highest power in my polynomial. The next number I write down has got to be the coefficient of x cubed. Well, you look at that polynomial, and there is no x cubed in the polynomial. Well, the coefficient of x cubed is 0. There are no x cubes. Same thing with x squared. This is the x, and this is the constant. Okay, so when you're doing the synthetic division process, these coefficients need to be in descending order based on the power of x that they correspond to. So the one that's on the extreme left needs to be the highest power, and then the next highest power. So in our example, this was corresponding to x to the 4th. This thing needs to be coming from x cubed, x squared, x, and the constant. Okay, now what do we put here? We're going to put a -2. Why is that? Well, the question is, what makes the divisor equal 0? In this case, the divisor is the polynomial x plus 2. What value of x makes that 0? It's -2. All right, so now we go to town using the synthetic division process. Whatever's here, drop it down. 6, multiply by -2, -12, add -12. Multiply by -2 for a 24, add for a 24. Multiply by -2 for a -48. Add these guys. -57. Multiply. 114. Add 116. Okay. So my remainder is 116. So this division did not come out evenly like the last one did. So x plus 2 is not a factor of that thing up there. But we can always do a division and get a remainder, get something left over. Now, I need you to kind of think back to like grade school here, okay? Like if I was to do 5 and divide it into 37, 5 goes into 37 7 times with 2 left over. There's your quotient, there's your remainder. Okay? 5 times 7 is 35. That's as close as you can get using multiples of 5, and you're 2 away from the target. So, same thing there. There's something left over. Okay, so the quotient from this operation is, now I like to do it backwards. I write it backwards. -57, that's your constant, 24x. -12x squared. And then 6x cubed. Okay? So the last number is going to be your remainder. The last number is your remainder. Then your constant. Then your coefficient of x. Your coefficient of x squared. Your coefficient of x cubed. If there was something over here, it would be for x to the 4th. Okay? Just like with these numbers on top, these coefficients of the quotient are in order according to the powers of x. Okay, they're in order according to the powers of x. So there's the quotient, and there's the remainder. The remainder is 116. All right, so the good news is that the synthetic division process is actually pretty easy. Once you get practice with it, it's actually kind of a breeze. The only things you have to be careful about is making sure you get the setup correct. So remember, coefficients have to be in descending order according to the powers of x. Don't forget, you may need placeholder zeros. If your polynomial is missing powers of x, like ours was, You need to account for that in your setup. Okay, so you got to make sure you get the right setup. Put the right number in the notch, put the coefficients in the correct order, and use placeholder zeros as necessary. So that's the first thing. The second thing is make sure you interpret this correctly. Know what this is telling you. It's telling you the remainder. If your remainder is 0, that means you have found a factor. If the remainder is non-zero, then you haven't found a factor. The division didn't go in evenly. And don't forget, these numbers over here also tell you something. They tell you the coefficients of the quotient. Okay, so make sure you practice the exercises that I'm going to assign so that you get this synthetic division process down pat.